Wastewater treatment in Musaliar College. Abstract: the area of our project is the planning and designing of wastewater treatment plant in Musaliar College of Engineering and Technology, Pathanamthitta. There is a lot of water is wasted in the college campus. During summer season availability of fresh water is less. The main objective of this project is to reduce the demand of potable water and generate the new source from reuse of wastewater. Wastewater treatment process is designed to achieve improvements in the quality of wastewater. Wastewater treatment is closely related to the standards and expectations set for the effluent quality. The campus requires a huge amount of water for different purposes like cleaning, gardening, etc. So to fulfill the demand of water we work on treatment and reuse of wastewater generated in college departments and hostel. Thus it reduces the load over fresh water, and to reduce the demand of fresh water, treatment is required for wastewater and then it is utilized. Keywords: wastewater, treatment, reuse, chemical parameters. Introduction. The study at Musaliar College focuses on the planning of a new water source. The campus lacks water source inside the compound. Large amount of water is needed for the daily use. During summer season, the availability of fresh water is very less. In order to overcome the situation, a new method is proposed. This is by treating the wastewater from the wash basins, cooler. In hostel the water after washing the clothes is also used for the treatment. By treating this water a new source is generated and this water can be used for washing, gardening except for drinking purpose. Scope: to conduct necessary studies regarding the planning of a new wastewater treatment method and thereby reducing the problem of water scarcity. To determine the chemical and physical characteristics of the water. This method improves the overall efficiency and method used here is cost effective. Estimation is also calculated for analyzing the cost. Methodology. Data required. 1. Quantity of wastewater generated in college departments and hostel from wash basins, bathrooms. 2. Total number of students and staffs in each department and also for hostel total students in the hostel is calculated. 3. Characteristics of water. 4. Indian standards of irrigation water. Methodology. In this first the wastewater is analyzed and the chemical characteristics of the water is tested. Next is the selection of the treatment method. Then the filter media is selected and the design of the filter media is carried out. Then the treated water is again tested. Finally the analysis of the treated water is carried out. 1. Analysis of wastewater. In this the amount of wastewater generated is calculated. For the calculation, the amount of water used in various department by each student for washing is taken as 1.5 L/head/day and the water used by students in the men's hostel for bathing is taken as 30 L/head/day. These are then multiplied with the number of people using per day gives the total quantity of wastewater generated in each day. 2. Testing of the wastewater from college and hostel. In this the chemical and physical characteristics of the water is calculated. Some parameters like BOD, COD, turbidity, chlorides, pH etc. are important in determining the water whether it can be used for any purpose. 3. Selection of treatment. Preliminary treatment is done by passing it through the meshes. In domestic wastewater treatment, preliminary and primary processes will remove approximately 25% of the organic load and virtually all of the non-organic solids. Then the water is passed through the filter media in the primary treatment. Finally it is passed to another tank for the secondary treatment. Secondary treatment is the biological treatment. Algae is used for the biological treatment. Components of the filter media. 1. Activated charcoal. It is the activated carbon which has high adsorption capacity. Due to its high degree of microporosity, just 1 gram of activated carbon has a surface area in excess of 3,000 square meters as determined by gas adsorption. Activated charcoal traps impurities in water including solvents, pesticides, chemicals etc. Size selected is less than 75 micron. 2. Sand. Sand bed work by providing the particulate solids with many opportunities to be captured on the surface of the sand grain. These captures by surface charge repulsion mechanism. The sand of size 1 mm to 1.36 mm is used for this filter. 3. Aggregate. Filter gravel is used as a support media to filter sand. For maximum efficiency aggregate should be rounded than angular. Size is about 10 mm to 12.5 mm. Results and discussions. Test results of the wastewater from various department and hostel are discussed below. 6. Conclusion. On the basis of experimental result, it can be concluded that filtration treatment by using activated charcoal, fine sand, aggregate are successfully executed. This experimental study also found that this filter is more effective for removal of TDS, chloride, hardness due to Ca and Mg, suspended solids, and phenols. The water obtained from the designed filter is very pure and the water is free from impurities, odor, taste, dissolved solids, and turbidity. The water has no carbonates and bicarbonates of calcium and magnesium, so there is no problem of temporary and permanent hardness and the water can be used for laundry purpose. The fact that the water can also be used for cleaning and gardening purpose is an additional advantage. The activated charcoal is available easily, cheap and has high degree of purification. The density and large surface area available for adsorption is an important factor. This process has so many advantages and aim to meet all the needs of the present situation. Through this study it is concluded that a new source is generated for purpose of irrigation and it reduce the load over potable water demand.